Okay, we're going to look at some velocity questions in this lesson. Velocity, a lot of the questions are talking about speed of maybe aircraft or somebody on a boat or hiking, any type of movement. So when we're talking about planes, the airspeed is the speed of the plane by itself. So it's the magnitude of velocity produced by the engine. If we talk about wind speed, we're talking about just the magnitude of the wind pushing the plane, or perhaps it's going against the plane. And then we're talking about ground speed. Ground speed is the airspeed and the wind speed together. So it's referred to ground speed because if you were standing on the ground and you were looking at the plane, you were looking at the speed of the plane and the wind together. So for example, we might have a plane headed due south at a speed of 300 kilometers per hour, and there is a wind from the west at 100. So the first thing that we would like to do is draw a diagram. So if it is going due south, it is going towards the south at 300, and it's meeting a wind from the west. So if it's from the west, it is headed east. So we'll do this tip to tail. Here's the wind, that's 100. So we've created a right angle triangle, and our resultant or our ground speed would be going in this direction. So since we've created a right angle triangle, we can use Pythagorean theorem to determine the magnitude of the ground speed, which is the wind, which is 300, or the plane, which is 300, plus the wind, which is 100. And so if we do that calculation, we end up with a resultant speed of 316.2 kilometers per hour. And since we have it, again, as a right angle triangle, we can find the angle. So we want to find this angle here. So we can use tangent. We have the opposite side 100 over the adjacent 300. And that angle works out to be approximately 18 degrees. So if I'm measuring that in quadrant bearing, I would say starting at the south, we are headed 18 degrees towards the east. If I wanted to write it as a true bearing, I would have to determine this angle connected to the x-axis first. So if this is 18, then this angle would be, what's that, 72. And then this is 90. And so together, these together would be 162 degrees. In this example, we have a plane that has a direction and a speed traveling for an hour and 15. And then it turns in a different direction for another 2 hours. So the first part asks for the displacement, which is the distance traveled. So let's do that. So the first part, they're traveling at 240 kilometers per hour for an hour and 15. So we'll write that as 5/4. An hour and 15 is an hour and a quarter. And so that works out to be a distance of 300 kilometers. And then the second part of the trip, they're traveling at the same speed, this time for 2 hours. So that's 480 kilometers. And so I'm going to draw a diagram to find part B. Part B says find the total distance. So first I'm going to do tip to tail, and then I'm going to do components to show you that either method is fine. We'll end up with the same result. So the first leg of the trip, they're going north 20 west, which is approximately this direction, 20 degrees. From there, they're traveling north 80 east. So what we can do is draw a second quadrant bearing and do our tail here. This is going north 80 east. And so our resultant would look something like this. Okay. So we know the first leg of the trip is 300 kilometers and the second leg is 480. So we want to find this angle in between so we can use cosine law. So we do have an alternate angle if this angle is 20, then so is this angle, because we have alternate angles, right? We have that Z pattern where we have two parallel lines, both going north, and so the angles alternate are the same. We have a 90-degree angle here, so if this is 20, this is 70. And then above it, same thing. If we have 80, then this angle is 10. And so our total angle in between is 80 degrees. So we're going to use cosine law. So we have both sides. And then we know that the angle in between them is 80 degrees. And so we'll do that calculation on our calculator, and that works out to be 520 kilometers. So that's our resultant magnitude, the distance traveled. And then we would want to find the angle. So we're going to use sine law. We know the displacement. The resultant is 520. It's across from the angle 80. We want to find this angle here. So we're going to use the 480, which is across from it. And if we do that calculation, that works out to be about 65 degrees. I've just rounded it to the nearest whole degree. So if I'm measuring it by quadrant bearing, I'm going to take that resultant and subtract the 20 degrees that is on the left, because I just want the little bit that's on the right, which is 45 degrees. So its resultant bearing would be north, headed 45 degrees towards the east. Now, we can also do this question in components, if that's your method of choice. So we can do, I'm going to call the first leg of the trip vector 1, and the second leg vector 2, and then we'll look at the total. And then we want to find the x component of the first leg and the y component of the second. So I'm going to draw an individual diagram for each. So the first leg of the trip, we went north 20 towards the east, or the west. So when we connect to the x-axis, we are using a 70-degree angle to find the x and y component. So this leg, we went 300 kilometers at an angle of 70. And you'll notice that the x is going left, so that's going to be negative. So that works out to be negative 102.6, and we're going up, which is positive 281.9. The second leg of the trip, they're going north 80 towards the east. If we connect to the x-axis, that makes this 10. And so we'll use the 10-degree angle with the 480 displacement. And both positive because they're going right and up. And then we'll total that up to find our resultant. So you can see that both x and y components total are positive. That means that the resultant is going right 370 and up 365. And so we've created a resultant triangle that is a right angle triangle, so we can use Pythagorean theorem with the resultant components to determine the magnitude. And that works out to be 520, which confirms our answer using tip to tail. And then we would want to find this angle here. So we can use tan, opposite over adjacent. And that works out to be, let's do that calculation, that works out to be 45 degrees. So we're going north, 45 towards the east. Okay, if this is 45, then so is this. Okay, so either method is fine. You can use tip to tail or you can use components, whatever your preference is. Okay, I'm going to skip over this one because it's similar to the last one. So let's do the next one. So this one is 3 legs of a trip. So you have a hiker going 500 north 30 east, then they go 430, 840 south, and then they go 200 north 10 west. So you want to know the total distance or the resultant vector and in the direction. So when we have 3 vectors, it is much easier to use components. Okay, we can do tip to tail if you want, but it gets quite tricky because you have to do the first 2 components together, the first 2 vectors, and then take that resultant and then do the third one, which is fine. It's just a little more complicated. So let's do components. Actually, I'm going to draw my diagram first. Okay, so let's draw our 3 trips. So the first trip, we're going north 30 towards the east. So that's going to make an angle that is 60. And we're traveling at 500 meters. The second leg, they're going east 40 south, which is described a little differently than we normally do. So it's starting at east, going 40 towards the south, but that's fine. So we get that. And that's going 430 meters. And then the last leg, they're going north 10 towards the west, which is in this direction. Make our right angle triangle with the x-axis. So we're going to use the 80-degree angle to find that. And that's traveling 200 meters. So we're going to put a table together here. So we've got vector 1. So vector 1 is traveling 500 meters, cosine of 60, and 500 meters, sine of 60, both positive because they're going right and up. So we'll do that calculation. The second leg of the trip, we'll call that vector 2. That one's traveling at 430 at a 40-degree angle. It is going right, so positive, and it's going down, so negative. And then the third leg of the trip, 200 meters at an angle of 80. We're going left, so negative. And we're going up, so positive. So those are our 3 legs, and then we're just going to total it up to find our resultant. So total works out to be 544 and 353. And so both positive. So that means our resultant is going to be in this direction. It's going to be right 544 and up 353. And we're going to find the angle here. So we're going to use Pythagorean theorem with our resultant components. And that works out to be 649.4 meters. And then the angle, we'll find the direction. And that angle works out to be 33 degrees. So if this is 33, then this angle with north is going to be 57. And so our resultant in quadrant bearing would be north headed 57 degrees towards the east. Okay, we'll do one last one here. This one's a little bit different. You have a pilot that wants to go in a certain direction. So in this question, we want to find the direction they should steer the plane. So if you think of a plane being pushed by the wind, So let's draw a diagram here. So we want to go south 20 towards the east. So this is where they want to go. So that's going to be our resultant, or the ground speed. The wind is coming from north 80 east. So we're going to reverse that. So whenever we see the word from, we're going to reverse the direction. So that means it's coming towards south 80 west. So the wind is coming from south 80 west. Actually, let's just erase this here. So if the wind's coming from south 80 west, we're going to have to point the plane somewhere in this direction so that when it meets the wind, which is coming from south 80 towards the west, the wind is going to push the plane, and then it will result in the direction of north 20 towards the east. So the plane, a little bit messy here. The plane we know is traveling at 520 kilometers per hour. The wind we know is traveling at 46 kilometers per hour. And so in this type of question, we want to find the direction first. We want to find this angle first. Because we don't have enough information to use cosine law yet. So if this is 80, so we know 46 is opposite the angle that we want. And we want to find the direction. So we're going to use the 520 because we know that side. So we need to find the angle opposite the 520, which is this angle. So we've got a Z pattern here. If this angle is 80 from the wind, we know this angle is 80. And we have a Z pattern on the other side. If this angle is 20, then this angle is 22. So we know this angle opposite the 520. So we can use sine law. This is part A. So we know 520. We know the angle opposite it is 100. We know the wind is going at 46, and we want the angle opposite that. So if you do the calculation, that works out to be 5 degrees. So the direction that we want to head the plane, you'll see the red line is the resultant. That's the plane. That's the direction we want to head the plane. So we want to go this direction, which is 20 plus 5. So we want to head the plane south 25 degrees towards the east. Now that we have that, we can do part B, which is the ground speed. So we want R. So we can still use sine law because we know all the angles now. So we want the resultant speed, so R. And we need the angle opposite it. So if this is 80, this is 10. And here we have, we want this inside angle here. So we've got a Z pattern here. We know this is 25. So this inside angle is 65. So the total angle opposite R is 75. And then we can use either of the other two. I'm going to use the 46, which is opposite angle of 5 degrees. And we're going to do that calculation. And that works out to be 510 kilometers per hour. So when you have a question where you want to know which direction the plane needs to point in order to find the resultant, you need to first find the angle that you're going to point that direction. So we're going to use sine law, and then we can use sine law again to find the resultant magnitude.